Good afternoon, class. Today we'll be learning graphing linear equations in standard form, 3.4.
All right, thank you. All right, so when you graph linear equations, how many people remember the y equals mx plus b? That's called slope-intercept form. That's a line, little different than what we're doing. We're looking at what's called standard form. Okay, so on your notes, it says the blank, the standard form of a linear equation looks just like this. Okay, when you have an actual problem, the a, the b, and the c will all be numbers. Okay, here's an example of an actual problem. In this case, a is 2, b is 3, c is 6. Okay? So these are the kind of equations we're going to look at today. They're still equations of lines. It's a little different than y equals mx plus b. Same shape, different way to write it. That's all. Now, in general, when you graph a line like this, it usually has a slant to it. Maybe it looks like that. Maybe it looks like that. If it's slanting up, that's a positive slope. If it slants down, it's a negative slope. But there's two special cases. There's the case where it's straight up and down. And then there's the case where it's perfectly left and right, okay, horizontal. So, I'm going to show you the two special cases. Okay, and then we'll practice graphing. If you have an equation that is y equals, and then a number, that is a horizontal line. Y equals a number. Will, can you give me a number?
Any number?
Yeah.
67.
67. So if you had y equals 67, y equals, says it right there, horizontal line. Where would the horizontal line be? In this case, it would be at 67. Be way, way up. Here's another one. This one is y equals 3. The first part right here, when it's just a y, okay? Where's the x in what I circled? Well, in what I circled on the board, where's the x? Because we said this is standard form, right? Something with an x, something with a y, equals a number. So I'm asking, where's the x where it says example? Where's the x in here? It's not there. That's what makes it horizontal. If you don't have the x, it's just y and a number. Okay, so that's a special case. Okay, normally you're going to have a number with x. You're going to have a number with y. And you're going to have another number. If you're missing this part, and it's just y equals, that's what makes it horizontal. So that's a special case.
Are we copying this down?
Yeah, it says right up. It says two special cases. There's a number 1 above that graph. You want to write in that information. If we have something that's underlined, if we have an equation in the form of y equals number, this is a horizontal line at the number.
No, like are we copying the graph?
Yeah, copy the graph down on the graph below.
Okay.
Oh, okay.
Guys, see the graph? See the first graph on the top on the left? And there's a number 1 written there.
Yeah, it's up there.
Number 1. If we have an equation on the line,
It's already written above the top.
it's written above it?
Yeah.
Okay, good. You don't have to copy that.
Yeah.
That's for the first one. Yeah. So
Okay, so
where it says 1 on the line, where it says 1, just cross it out. You'll have to copy the next one for 2. That's all. All right. And then you want to make sure you draw your line and make sure you write in y equals 3, so you know what line it is.
So
it's on the graph below it.
If y equals is horizontal, what do you think the other special case is besides horizontal?
Vertical.
Vertical. Anyone have a guess what letter that's going to be? X equals. Okay? Look at that one.
So that's what it says number 2. When it says number 2 on your guided notes, you want to write that in.
A whole ring?
The whole thing, yes.
Must be pretty outfit.
Okay, so this is another special case. Why is it a special case? Because look at what I just circled. Is there a y in anything I just circled?
No.
No. So if you're missing the x, it's a special case. If you're missing the y, it's a special case. You have to know which one it is. X equals a number, vertical. Y equals a number, horizontal. Right, and there's the case where it's at 5. How do you know it's at 5? Just count. 1, 2, 3, 4, 5. It's a vertical line at 5.
I think that's another way that you can think about it is this. You can graph this number. When it's a special case, graph this number, whatever it is, on this axis, on the x-axis. So I graph 5 on the x-axis, and I draw my line opposite of the axis. I don't want to have it going horizontally. I won't see it. It'll be right on the x-axis. I don't want that. So another way you can think of it is graph this number on this axis and draw your line opposite of the axis. That's another way to think of it. Okay? You can't remember what a vertical line is and a horizontal line. Right? That's another way to think about it.
So other than these two special cases, every other formula is going to look something like this. It's going to have the x in it and the y in it. Okay? We haven't really talked about what that would be, but it wouldn't be horizontal and it wouldn't be vertical, so that only leaves something like that. It's going to be slanted. Or maybe it's going to slant the other way. We'll talk about how to graph it. Right, so let's look at an example. Y equals 4. Okay, first, can somebody tell me, is that a special case? Yes?
So
Why?
it goes like this. Because
Yes.
it's Y.
Right.
Vertical.
First of all, it is a special case because you only have one letter. Now we have to decide vertical
No, it
or
goes like
horizontal.
this. Yeah, that one.
Right? So like Mr. Royce said, graph that number on that axis. Where's 4 on the y-axis? Up or down? Up.
Buck, buck.
And now you always draw the line opposite the axis. Because if you drew it right on it, you wouldn't see it. Right?
Oh, yeah.
So draw it so you can see it.
What?
Oh, I get it.
So y equals 4. Put a 4 on the y-axis and then draw the line opposite the axis. Or just memorize y equals is horizontal. However you want to remember it, either way. Okay, so that's y equals 4. Okay, let's look at that one. Is that a special case?
Yes.
How come?
There's only one letter.
There's only one letter. You don't have both x and y, so you got to do this one special. Where are we going to put the -2 on? Which axis?
The left side.
The x-axis. So that's the left side, yep. And now how would you draw your line?
Up and down.
Right, because if you drew it right on the axis, you wouldn't see it.
Yeah.
Right, if it was the same color. So vertical line, let me do a nicer job. Vertical line, right on -2.
Perfect.
Make it a little thicker so you can see it. There you go. Okay, any question on that?
Can we go back to the other one?
Go back to the other one?
I forgot to draw it.
Okay, so y equals is which way?
Or this way.
Left, horizontal, x equals?
Along the horizon.
Vertical. Okay, anybody need to copy either of those graphs?
I'm copying it right now.
Do.
Never mind.
And guys, some of this stuff you're not, only the stuff at the end, you're gonna have to copy down on this. You're gonna have to write it all there. It's gonna be the fill in the blanks. But the first couple things you don't have to worry about.
Okay, so when you're drawing a line, how many points do you need? 2. That's all you need. How come you can't just draw 1 point? Hey, if I said draw a line through that, you could go like this, you could go like that, you could go all different ways. But if you have 2 points, how many lines go through both those points?
1.
Just 1. It's exactly the line that looks like that. So how many points do you need to draw a line? 2. Since you only need 2 points to graph a line, we can use that idea to graph equations. All we have to do is find 2 points and then connect them.
Guys, you don't need to copy any of this down. I'll tell you when you need to copy it down. It's on the back side anyways.
Okay, so I'm just telling you what we're going to do. We're going to find 2 points like that, and then we're going to connect them. Okay? And actually, we're just going to draw, we're not even going to connect them. We're going to draw right through them. Okay? So, to graph an equation in standard form, we're going to find what's called the x-intercept and the y-intercept. I think we've talked about it before, but can anyone tell us what's the y-intercept? That's where.
If you had to describe it.
What is the y-intercept of a line? It's where the line does what?
Isn't the y-intercept is where the slope of the line hits on the y-axis?
Exactly.
Yeah. So, just to show you, if you had something like this, x, y, there's your y-intercept right there. What do you think the x-intercept is? Yep.
Where the line intercepts on the x-axis.
Right. And if you could find, like let's say you were sketching a graph by hand, and you could find that point, and you drew it, and you could find that point, and you drew it, that's all you need. Now just take your ruler, draw your line. But the key is we have to find those 2 points. That's what we're going to show you how to do. Okay? All right. So we just went over that.
So guys, on your notes, you have the little top 2 blanks where it says recall. So the first one is the x-intercept, is where the graph crosses the x-axis, and the y-intercept, like we just talked about, is where the graph crosses the y-axis. So Mr. Hager just showed you that in a picture. He showed you that how they cross and what they are.
Now, the way you find the x-intercept and the y-intercept, it's a little, when we write it down, you're going to see it's not quite what you would think. Like you have to plug in a number. And you might think, oh, if I want the x-intercept, maybe I plug in for x. No. And if you want the y-intercept, maybe I would plug in for y. No. It's going to be the other way. So if you want to find the x-intercept, you have to plug in a number for the y. So when you want x-intercept, plug in 0 for y.
So it's like you're plugging in 0 for the opposite of what you want to find. If you want to find x, plug in 0 for y. If you want to find y, plug in 0 for x.
Opposites attract.
Now, guys, just as a reminder before we look at this, this is not for special cases.
No.
We already did special cases.
Yes.
Okay? This is for a problem like that. You have an x and a y. You have an x and a y. You have an x and a y. Okay? You don't have to do what we're doing now for special cases.
Yeah. Like Mr. Hager said, special cases is when, how do we know when it's a special case? Someone tell me by raising their hand. How do you know when it's a special case? Josiah?
You only have one x or one y.
Yeah, you're only gonna have an x or a y. You're not gonna have both. It'll be x equals something, or y equals something. There's only one variable. And guys, when we're doing these kind of problems, we're only gonna use x and y as a variable. You have to. We're not gonna have any A's or C's on the test. It'll always be x and y. That'll never change. Alright? So, like Mr. Hager just said, he makes a good point. You can only use this idea, the x-intercept, plug in for 0, this idea right here, you can only use that when you have x and y in the problem. Special case, you're set to go, just graph it. Because when we do these next couple, we'll have to do a little bit of work and then graph it. When we have special cases, we can just go ahead and graph. Alright? So you guys have this written on your thing, or you have the, on your guided notes, you have this example. So it doesn't matter. You can solve for the x-intercept first. If you want to go in alphabetical order, you can solve for the x-intercept first. You can solve for the y-intercept first. There's no wrong way. You're not wrong either way. You're going to get the answer. Me personally, I would do the x first just to keep it consistent, because it's first letter. If we're going alphabetically, do the first letter. So I want to solve for the x. I'm just going to put x int. So I'm going to solve for the x-intercept. Alright? Someone tell me what I need to write if I'm solving for the x-intercept. Sydney?
You would plug in 0 for your y.
Plug in 0 for y. So what do I write?
3x plus 4, and then versus 0 equals 12.
Now, does that look kind of similar to what we did in the warm-up?
Yeah.
Yeah, that's why we did it. Alright? Now, who remembers from the warm-up when I had this 4 with the 0 next to it? What did I say you could do, Joe? Just cross it up. But just make sure the number that's there, the sign that's to the left of it, also disappears. So that positive 4 is gone as well. So this just disappears. Again, you can do 3x plus 0 equals 12. I get the 0 because I did positive 4 times positive 0 just gives me 0. Anything multiplied by 0 is 0. But I don't want to do that, because then I got to think, okay, I got to subtract, move stuff. 0, 0. It doesn't matter. But we don't need to write it there. So there'll be one extra thing to write, so it's going to screw us up. I'm just going to bring this down. 3x equals 12. Jack, what's my last step to get x?
You divide 12 with 3.
Divide by 3, right? So what do I get when I do that?
4.
X equals 4. Good. Now, we're going to come back to that in a second. Let's solve for y first, and then we'll come back to that. Right? So now, I want to solve for the y-intercept. So I'm solving for the y-intercept, right? So, well, when I solve for the x-intercept, I plugged in 0 here. Now I want to solve for the y-intercept. So what do I have to do? Where am I plugging in 0? For what letter?
Y. X.
Good man. So what do I write?
You write 3,
Yeah.
0,
Good.
parentheses,
Yeah.
plus 4y,
Yep.
equals 4.
Excellent. Good. Let's go down. Let's scroll down a little bit. All right. What did I say? What should we do next? Like Joe just said, forget about the 0 multiply. We don't care. It's going to come out as 0. What am I left with? Fred, what am I left with? I just canceled that out with 3 times 0. So what's left up there? That's actually 4y. I'm sorry. Actually a y. 4 what? What does this say here? 4 what? Keep going. Yeah, 4y equals 12. I'm just going to rewrite it a little bit neater. 4y equals 12. Haven't you solved an equation like that before, Fred?
Yeah.
What do you do? Divide by what number? 4, you got it? Yeah. I know my handwriting was kind of bad, I apologize. Y equals, do you know, Fred? 12 divided by 4?
Oh wait, the way I'm dumb.
Sophia, 12 divided by 4? 3. Good. So now I've
Always
got,
gonna be, I have a question. Is it
Yeah.
always gonna be like that?
always going to be like that.
You mean no
But
fractions?
because the numbers. No,
Oh.
because the numbers. Like, y equals 3 and x equals...
Oh, you're saying like whole numbers?
No, is it always gonna be flipped around like that? 'Cause then
No,
I
it's not always going to be like that.
Oh, that's just a coincidence. Yeah.
But good question. Alright, so now here's the thing. We did the first part, we used the intercepts to graph the equation. Label the points corresponding to the intercepts. So it wants us to give, we know what the x-intercept is, right? What do we get for x? 4. But again, we're graphing a point. So how many coordinates on the grid, how many coordinates does a point have? 2, right? So the x-intercept would be 4, comma, it's not going to be 3. What's it going to be? 0, right? I have nothing for, remember, this is not, that y equals 3 is not the y coordinate, it's just the y-intercept. It's not 4, comma 3. This is going to be 0. X-intercept, the y-intercept, let me scroll down a little bit so we can see it. Y-intercept is 3. Is that going to be my first coordinate or my second coordinate? What do you think, Noah? Is the y going to be my first coordinate or my second coordinate?
Give me the second.
Why?
X always goes first.
Because it's a y. Good. Perfect.
What did you guys plug in for x to
For my-
find that?
Oh, 0.
0. So there's my 2 coordinates. 4, comma 0, 0, comma 3. Like Mr. Hager made a good point. What did you plug in to get 3? 0. What did you plug in to get 4? 0. All right? Decide.
Why is 0 before the 3?
Because that's the. I'll show you when we graph them. It'll make sense. Let me show you. All right. So x-intercept 4, comma 0. Where's 4, comma 0 on my graph? On one axis. Y-axis or x-axis? Good. What direction am I going? Left or right?
Right.
How many?
4.
1, 2, 3, 4. There it is. It's 4, right, on the x-axis. But for my y-coordinate, I don't go up or down. I don't go anywhere. That's why it's 0. 4, comma 0. Now I get a graph 0, comma 3. So x, on what axis will that be on? The y-axis. Where am I going? Up how many? 3. 1, 2, 3. There they are, right there. There's my 2 coordinates. Right? Mr. Hager, I think he's going to draw that line for us. So, guys, where it says in the directions, label the coordinates. That's what you just did, right here. On your homework tonight. On the test on Thursday, it's going to have a spot for you to put the coordinates. Just write it in. When you get the x-coordinate, just put 4. When you get your x-intercept, just put 4. Your y-coordinate is 0. When you get your y-intercept, your y-coordinate is 3. Your x-coordinate is 0. Josiah, does that make sense now how we got 0, comma 3?
Kind of does, but I still don't know how to graph, so it's just confusing.
Right, like we said, if you just know what these are, x,
Yeah, why did you do it there and not the other boxes? Like, what's the significance to that?
what other boxes?
The smaller ones down there.
What?
The tiny square. The tiny square.
What do you mean?
Josiah, do you have a question on how to graph the coordinate 4, comma 0, like left, right, up, down? So when you have an x value that's positive, this means you go to the right 4 units. So starting from the origin, you go right 4. And then this means this is the up and down, but the up and down is 0. So you just go right 4, don't go up and down at all.
Yeah, the x is right and left. If the x is positive, go right that many numbers. If the x is negative, go left that many numbers. Right? If y is up and down. If y is positive, go up. If y is negative, go down. You good now? Good. So I'm going to bring this back down. That's it. That's all you have to do. Like I said, where it says label the coordinates, we did that right there. Like I said, on the homework tonight, you'll have to do that. On the test on Thursday, you have to do that as well. Alright? Let's look at this one. Same exact thing. How is this one a little bit different than the one we did before?
Oh, the y doesn't have a number.
The y doesn't have a number. The y doesn't have a number attached, but that's okay.
Do we still plug with it?
We'll still plug in 0. Exactly. The only thing is there'll be no multiplication. Let's do x-intercept first. Do our x-intercept first. Jack, to solve for my x-intercept, what do I have to do?
You have to divide 4 and 2.
Alright, I'll divide 4 and 2. How do I get there though? I gotta do something with a certain number for 11.
You have to divide y to get the division.
I gotta do something with the number 0. What do? If I'm solving for the x-intercept.
You have to divide.
Not a division. I have to write this problem out first before I can get the division part.
You have to.
No, I know what to do? To solve for the x-intercept, what do I have to do?
Let me get my shoes on. Hold
Yeah, why don't you put your slippers on there, buddy?
Thank you, Joseph.
What do I have to do to solve for the x-intercept?
Oh, we do 2x
Plug in something, yeah.
Plug in something, yeah.
plus 2.
Well, there's a minus sign there, buddy.
Oh, okay, 2x.
Minus. I don't like that number you said though. There's not gonna be 2.
I thought it was a plus. Never. Oh. Yeah, maybe I don't know.
I'm kind of confused now.
Wait, hold on. 2x.
Hold on, let me see the
Would you
moment.
plug in 0 for y?
Yes. Exactly.
But that's not the. Oh, wait, maybe it is.
That's what he just wrote, yep. Plug in 0 for y.
Yep. Equals. This one's just a little bit different because, like we said,
Oh, we did.
when
Can I do
But that doesn't work. 2x
Yeah,
minus
you do.
0
You would either
equals,
cancel
does
out
it
the
equal
0
4?
Exactly.
plus 0 and then it's still be 4 and then
Zero
it'd be
to both
2x
and guys,
equals
if you
4.
listen to me, if you want to, if you know you're solving for the x-intercept, you know the y disappears. Like I think that's what Jack was getting at. If you just want to, again, I just don't want you to make a mistake and be careless. But if you know this y is going to disappear, you just want to write 2x equals 4. You can do that too. If plugging the y in there, plugging the 0 in there is screwing you up, you just want to totally eliminate what's being attached to the y, that's fine. You don't have to write it. I'm just showing you that how the whole process works. Now I'm left with 2x equals 4. Paige? So stop please. Huh? 5 by 2. Guys, stop with the pens, please. It's annoying. Whatever it is. Huh? X equals what, Paige?
X equals 2.
So, Paige, what's that coordinate going to be when I write it over here, when I label it?
2, 0.
Excellent. 2, 0. Very good.
Every
Well,
intercept always has a 0 for one of the numbers.
Yep.
Always.
Now the y-intercept now. And guys, you don't have to label like x-intercept, y-intercept that you're solving for. I just think it helps to keep it a little bit more organized. It's up to you whether you want to do that or not. Alright? So now we're solving for the y-intercept. Alright? So to solve for the y-intercept, alright, Nathan, what do I have to do?
Chica.
Place x with 0, so what am I going to write?
Who's that?
Yeah? Now this is where it gets tricky, guys. This is where you have to pay attention. What am I going to cross out?
The 0.
And what else? The 2, right? Now here's the thing. Is that negative a part of this? This negative right here?
Yes,
No, it's not.
it's part of the y.
Exactly, Joe. Very good. We've talked about all year. The sign to the left belongs to that number or that variable. In this case, it belongs to the y. Is y by itself?
No.
No. To solve for y, we have a negative attached. What do we have to do? To solve for y, we have a negative, or a variable, we have a negative. Excellent. Divide by a -1. Divide by a -1. Divide by a -1. This is going to make this positive. I'm left with a y. Now we had one like this in the warm-up, right? 4 divided by -1. What do you get, Mallory?
You get
-4,
-4.
right? That is division.
Negative 200 divided by positive 60.
Yeah.
Oh,
Good. So it's -4. Josiah, you good?
Yeah.
Okay. Because when you say you don't understand things, you don't pay attention, it frustrates people. Doesn't help you, you're not helping your cause. Alright? So now, if I have to make this a coordinate now, right? Somebody tell me what that coordinate's going to be. I have y equals -4. Page?
0, comma, -4.
0, comma, -4, right? Like Mr. Hager said earlier, all right? You plugged in 0 to get 2 for the x-intercept. You plugged in 0 to get -4 for the y-intercept. Now I just have to graph them, all right? So, Josiah, how do I graph 2, comma, 0?
You would go over to
What direction?
like this way.
To the right, okay. Do I go up or down? Do I go up or down?
No.
No.
0.
To the 0. Very good. There's my x-intercept. Fred, how about graphing my y-intercept? 0, comma, -4. Stay on the x-axis, stay on the y-axis, okay? It's negative. Good job. 1, 2, 3, 4. There it is. Mr. Hager's going to draw the line for us. And there we go. Oh, the whole graph is moving. Good. So guys, does that make sense?
Yeah.
So sometimes, so help me out here. If I want to solve, raise your hand. Don't just scream it out. If I want to solve for the x-intercept, what do I have to do? Sometimes I raise my hand. Sophia?
Replace the y with 0.
Exactly. To solve for the x-intercept, you have to make y 0. Vice versa. Ginny, to solve for the y-intercept, what do I have to do?
Put the number, or you make the y 0,
Not the y,
the x.
x. Remember, do the opposite. Whatever intercept we're asking you to find, do the opposite. We're asking you to find x, make y 0. Asking you to find y, make x 0. Let's do the opposite of what it says. Right? Guys, another page of notes. Again, don't freak out. There's only one more example that we have to do together. Say, I'll take that if you want.
I'm sure. Joe, you're the one who wants to move math boxes.
Yeah.
We got one more page of notes.
I guess it was like this to do the line, and it just went right through as you got.
Sure, no.
Okay, guys, so while Mr. Roy is passing out the notes, I want you to
You're a bully.
read the problem. Okay, it says you're planning an awards banquet and you need to rent tables to seat 180 people. Okay, there's two size tables you can rent. You can rent small tables, or you can rent large tables. What is the cost? Or I'm sorry, not the cost. How many people fit at a small table?
6.
6. How many people can you fit at a large table?
10.
10. So there might be different combinations of tables you could get. Maybe you could get this many small and this many large, or a different number of small and large. The point is you have to seat 180 people. That's the equation that represents this problem. Okay.
So we plug in 0 for x.
Well, hold on, we're going to see what they want us to do. I don't know what they want us to do yet.
I thought we always plugged in 0.
If they want to know the intercepts, yep, we're going to read if that's what they want us to do. So x is the number of small tables, y is the number of large tables. So you would multiply, because 6 people fit at a small table. So let's say you had 5 small tables. 6 times 5, 30 small tables. 6 small tables would fit 30 people. If you had 5 large tables, 10 times 5, 50 people would fit. We have to fit 180. All right? So the first thing it says to do is graph the equation and label the intercepts, okay? Just like we did before. So let's start. Yeah, so we'll do that first. And then I want to find 4 possible solutions. Like I could get this many small, this many large tables, and it would fit 18 people. Okay?
We had 180 people.
180 people. Yep. Yeah, I meant 180 people. So graph the equation, find the intercepts. Let's start with the x-intercept. Can somebody tell me, how do I find the x-intercept? You don't have to tell me what it is, just tell me what I have to do.
You have to replace the y with 0.
Yes. To find the x-intercept, plug in 0 for y. Let's go back up. And we're going to plug, it's going to be 6x
plus 0.
Yeah, 10 times 0 is going to be 0. Equals
180.
equals 180. Now, do I need the 0?
No.
No, it's plus 0. So what do I have now?
6x equals 180.
6x equals 180. How do you get x by itself? Divide by 6.
And then you get 30.
X equals 30.
X is 30. Okay, so that's my what intercept?
x-intercept.
So when I go to graph it, 30, comma 0. It's my x-intercept. Let's find y-intercept. Okay, how do I do y-intercept?
Yeah, plug in 0 for x.
Plug in 0 for x.
Yeah.
Yep.
Good job, Noah.
So 6 times 0 is how much?
0.
0 plus 10y equals 180.
Yeah. So just 10y plus 1 equals 180.
Right, so the 0 is gone.
Divide 10 by both sides.
Divide both sides by 10.
18.
18.
Yeah.
Okay, so off to the side, or maybe down below, I'm just going to write my intercepts. 30, 0. How do I write the one with the 18?
0, 18.
0, 18. Yep. Okay, so any questions on that one?
I understand this lesson.
Now, does it say to graph it? Yeah, it does say graph.
We don't have a graph.
We don't have a graph.
Okay, just watch me graph it.
We have a graph on the back. Oh, great.
Do you have a graph on the back?
Hey, don't grab it on there.
They're
That's all right.
individual
This is
ones.
just watch, that's all.
So now, my values are kind of big, so if I go by ones,
Just go like 5.
we could probably go by
Times or
3s, 4s. I would probably, let's go by 5s. So we got 5, 15, 25. That'll be enough. Actually, I don't even need that. Well, yeah, I do need to go out to 30. And then on the y's, I need to go up to 18. So 5, 10, 15, 20. All right, 30, 0. How do I graph that? 30, 0.
go across.
Which way?
To the right 30.
Right 30.
And you stay there.
Right there. How do I graph 0, 18? Up 18. Now, we're going to draw a line here, and this line is going to represent all the solutions to the problem, the number of tables you could rent, all the different combinations. Now, can you rent negative tables?
No.
No, then you shouldn't be drawing down in here. That's negative. And you shouldn't be drawing over here. That's negative.
Stay to the upper right corner.
Right. So when we draw this, I'm not going to draw a line. I'm going to draw a line segment. Okay, it doesn't keep going. So now it's said to interpret what these solutions mean. Okay. What was x again? What size table did x represent? Small.
Wait, what was it?
And y represented what? Large. So let's start with 0, 30. What would that mean in terms of renting tables to fit 180 people? You could rent how many?
People rented 30 and no one showed up? 30.
Well, this is just all tables.
Yeah.
Oh.
So x is small, y is large.
30 small tables, 0 large.
You could rent 30 small tables and no large tables, and that would fit everybody. So this represents, this you want to write down, renting 30 small and 0 large tables. That's one thing you could do. If the company was out of large tables, you could say, all right, I'll take 30 small. How about 0, 18? What does that represent? Renting how many tables? Yep.
0 small tables, 18 large tables.
Yeah, if they didn't have any small tables, that's okay. You could rent 0 small but then you would need 18 large. So 18 large tables. So that's 2 solutions to the problem. Part B says find 4 solutions.
Yeah.
We already have 2. All right, so let's, for part B, your solutions. Break it down into 2 columns. Large, small. Large tables, we could do 30, small, we could do 0, and that would fit 180 people. We could do 0 small, or sorry, 0 large, 18 small. Now, every other combination is going to be a mixture of small and large. Let's look at our graph and see if we can figure out. Yep, 30, 0, 0, 18.
You could do 25 and
Let's make it bigger so we can see it.
You have 0 small tables, 18 large tables.
What would be another solution? We have to try to find a point that looks like it's on that line.
Oof.
Anyone see another one?
15.
Yep,
15 and 5.
I think so. Let's check it. 5 small, 15 large. To check it, how many people fit at a large table?
6.
10 people. So if we had 15 large tables and 10 people at each table, how many would that fit?
Some
150.
80.
Now, how many people fit at a small table?
6.
6. 5 tables of 6 people is how many?
30 plus 150 plus.
Oh, it does work. It does work. It does work.
It does work. So that's another solution. You could get 15 large tables, 5 small. Okay, the problem with our graph is I don't know if I can see another one that's at a nice spot. Okay, you could get 20 tables, but then I can't tell if it's 7. Might be 7. So we're just going to go with that one. Is it 7? Oh, we'll just go with that one solution.
I have a question.
Yes, Joe?
So when you go down to the table, like you have 30 down in the large and then 0 in the small.
Oh, did I reverse it?
Other way around.
Oh, thank you.
Are you sure about this one?
Like that?
Yeah.
Okay.
And then it'd be different with the 18 and 0.
And then, yes, I put them in the... Yeah, I should have done my columns the other way, Joe, but you're right. Is that last one right? Yes, the last one is right. But I probably should have done small, large instead of large, small, because that would make more sense, X,
That's what
Y.
I did.
Yeah, because I kind of did Y, X instead of X, Y.
That's fine.
Okay, but however you make your table, that's okay. So any questions on those 3? We're just going to do 3, not 4. Yeah, you just make a graph, and then you look where your graph crosses. If I was going to look at another one, I would say, it's kind of hard to tell, but it might be like 20 small tables and maybe 6 large or 7 large. I'd have to check it. Maybe, somewhere around there. Okay, I'm not exactly sure. Okay, so did we do everything? Graph it, find 4 solutions. We're good. Questions on that one? Okay, do you guys have a grid for example 4?
No.
Do you guys think we're okay with that one?
Yeah.
You guys, we may on the test on, you guys, the test on Thursday, we might give you a couple of we'll say you have 11 of these and 10 of these. So what you're really gonna have to do is just take and plug it in and see what works. All right, this is like taking it to the farthest we can go. But on the test on Thursday, we might just say, okay, you have 11 of these, you have 10 of these, you spent $3.70. Right? If you go over that amount with what we give you, then it's not going to work as an answer. All right? But I don't want to.
Yeah, I think this is good. This is kind of the same problem, guys. This is like saying we can fit 4 people at a small table, 6 people at a large table, and then going through all the same stuff again. Okay, so we're not we're not done. We have some practice
Yeah, leave those notes out.
problems, but just some reminders before we do the practice problems.
Wait, the beaver?
Yep, the progress reports close on Friday. So anything you need to make up, it's got to be into us by Friday. New material today, tomorrow, Wednesday. We have a half day on Friday, so the test is Thursday.
Wait, what's 180
We don't-
divided by 4?
180 divided by 4, 45.
Oh, that's what I was wondering. God, thank you. Smarter than me.
We don't have class on Friday. Period 7-8 does not meet. That's why we're doing the test on Thursday. Why were you asking about 180 divided by 4?
That's what, that's in the example 4.
Oh, example 4? Oh, you did that one? Okay.
Yeah.
Good, that's good, good job, good enthusiasm. So any questions on that? All right, so we've got some practice problems for you guys to take a look at.